Okay, problem number 4.
A ball rolls downhill with a constant acceleration of 4 meters per second squared. If it started from rest, how long will it take to travel 20 meters?
Draw a picture!
Okay, first I'm going to draw a picture of what is happening in the problem. Okay, so I have a hill that a ball is rolling down. Okay, so that's about the extent of my picture. So we get to choose which way is positive and which way is negative. So the problem says the ball is moving downhill. So to make things easier, because I don't like negative numbers, I'm going to call downwards positive. So over here, I'm just going to make a little note that downwards is positive, and that's going to make my life easier.
2. Label your nose. Your knowns. Label your knowns.
So now we got to label what do we know? What does the problem give us? So it says that the ball has a constant acceleration of 4 meters per second squared. And even though the ball is accelerating down the hill or speeding up down the hill, it's a positive acceleration because remember we called downwards positive. The problem then says that the ball starts from rest. That's super key. When you read that something starts from rest, now you understand that that means that the ball has an initial speed of 0. That the ball has a starting speed v0 of 0 meters per second. That means the ball is not moving at the beginning. So you can write that the starting speed is 0 meters per second. And finally, the problem asks how long does it take the ball to cover 20 meters? That 20 meters is a displacement. So the ball is moving down this hill, so its displacement is going to be along the hill. And remember, x minus x naught is displacement, and we know that's equal to 20 meters in this case. So I labeled everything I know. What am I looking for? What's the target? The problem is asking how long does it take the ball to do something? Well, how long means that we're looking for time. So t equals question mark. We're looking for time. All right, I have everything I know and my target. Now I need an equation with all of those things in it. So if you look at the first 3 equations on your equation sheet, those are the ones you're going to be choosing from for this problem because those are the equations you use for kinematics problems, like this one. So I automatically know I'm not going to use the 3rd equation because it does not have time in it. And I need time in my equation because that's what I'm trying to solve for. The first equation isn't going to work either because it has a final speed in it, a v final in it. And I don't know anything about the final speed of the ball. I only know about the starting speed. So I don't want to use that one either. In the second equation, I have an x and an x naught, an x minus x naught. I have a v naught. I'm looking for t, and I have an acceleration. So this equation will definitely work. So let's write it out. All right, there's my equation. Next step, plug in my zeros. Do I have any zeros to plug in? Yeah, for sure. My starting speed, v0, equals 0 meters per second because the ball started from rest. So I can plug that in here and this term goes away. So I rewrite it. Okay, my next step is to isolate the variable. I'm trying to get t all by itself. So I'm going to start with subtracting x naught. And next step is to multiply by 2 on both sides, and I'm multiplying to the entire side, so make sure you have those parentheses. Then I'm going to divide by a to get t squared by itself. I'm dividing everything by a, by the acceleration. And this looks like we're done, but we don't have t by itself. This is t squared. We want just t. So let's get to the root of the problem and square root both sides. I'm rooting for you, you can do this. So I'm left with t equals the square root of 2x minus x naught over a. And we are square rooting everything, okay? We have isolated t, so I can now plug in numbers. I'm going to do that over here. T equals the square root of 2x minus x naught. We know our displacement is 20 meters, divided by the acceleration, which is 4. And so t is going to come out to root of 10. You can plug that into a calculator if you want. I don't have one on me right now, so I'm just going to leave it like that, which is fine. And so we're done. Haha, no, this is the wrong answer because I don't know if this is root 10 potatoes, root 10 skateboards, root 10 iguanas. You have to tell me what this is. What I'm trying to say is you need units. So this is a time, and time is measured in seconds. Okay, so we have a numerical answer. Before we are done, we need to ask ourselves, is this reasonable? Well, when you're dealing with time, the first thing you want to make sure is that your time is positive, right? If somehow you got a negative time, that wouldn't make sense and you'd need to go back and check things. But we got a positive time, right? So that makes sense. Root 10 comes out to somewhere between 3 and 4, so just think, I don't know, 3.2 seconds. Again, you can always plug that into your calculator if you want to. But 3-ish seconds makes sense. You know, you didn't get like 400 million seconds for a ball rolling downhill. 3 seconds makes sense. So I like this answer. My final step is to present it. So I'm going to rewrite it. T equals root 10 seconds. And I'm going to box it so that it is easy to find. Okay, if you do choose to plug this number into a calculator, okay, so root 10 comes out to 3.162277601, etc. If you write your answer like this, with all of these decimals, you are going to get it wrong. On the AP test, I think the maximum you can do is 3 decimals. You cannot plug in a long string of numbers. You want to keep the number of decimal places to a minimum. So if I was to write this as a decimal for my answer, I would say that t equals 3.16 seconds, and that would be totally fine. Do not plug in 10 decimal places after the decimal point. You will get it wrong.